Hi guys, so we're going to learn about a new graph today called a phase change diagram. And the point of this is it will show you when a substance could be a solid or a liquid or a gas, and it's based on if we change the pressure and temperature values. So I like to call this a Y graph because it kind of looks like a letter Y, right? But there's lots of information secretly hidden on here. Another way that I like to call this graph is I call it the slug graph. So here's your slug. We have slug, SLG, whoop, just like that. So this slug graph works because on here we have to have hidden solid and liquid and gas. So it is a solid when it's over in that section. The substance would be liquid when it's here, and it could be gas if it's anywhere down in that section. So you just have to find which section you're in, and then you know what kind of state of matter that you have. So on this graph, we have two things. We have temperature and we have pressure. So you know that we always have to have units on our numbers. Temperature, your unit will be degrees Celsius. And pressure, it could be ATM, which stands for atmospheres, or it could be kPa, which stands for kilopascals. Now you don't have to guess, you'll just look on the graph. So like if I look at this one up here, this graph is in atmospheres. So it will tell you, just want you to know that atmospheres means pressure. So the other thing that we know about these substances is when a solid turns into a liquid, that's called a phase change. So I'm going to show you how that works and review the phase changes on this diagram. So first, we have this pair. You've got vaporization when a liquid turns to a gas, and the opposite of that is condensation when a gas turns to a liquid. So that will happen on the graph up above between the gas and liquid sections. So along this line, we've got condensation, or we have vaporization. So what that means is vaporization will happen when you start as a liquid and you turn into a gas. And condensation is when you start as a gas and you turn into a liquid. So it's crossing that line and you just have to think about which direction are you going. Okay? We have a couple other phase changes. We also have freezing and melting, which are a pair. So when it's a liquid to a solid, that's freezing. Melting is a solid to a liquid. So let's find the line up above between the solid and the liquid sections. Okay, so we've got that. Let me pick a different color here along this line. So we can have along this line melting or freezing. And so again, it depends on the direction that you're going. So freezing will happen when your liquid turns into a solid. And melting will happen when you start as a solid and cross that line and turn into a liquid. Okay? Last set of phase changes is we've got sublimation and deposition. Those happen between solid and gas. So those are down here on this little section of the graph. So you've got sublimation. Oh, let me write that again so it's neater. And then I'm going to try to squeeze deposition in there. Okay, so if I start as a solid and I turn into a gas and I cross the line this way, that is deposition. Or sorry, that is sublimation, starting as a solid going to a gas. The reverse would be starting as a gas going to a solid, and that would be deposition. So now we just have to do some practice reading things all over this graph. Okay, there's a couple other important parts on this graph. So you also need to know what's called the triple point. That's where all three states of matter coexist. Coexist just means this, that they exist together. Okay, we're coexisting here together right now. So if I wanted to see, here's my slug, where do I have a little bit of all of them? That is right here in the center. So that is the triple point. What that means is at that temperature and pressure, if I had a container, there would be a little bit of solid, a little bit of liquid, and a little bit of gas in it. Okay. One other important point is called the critical point. This is where the liquid and the gas are indistinguishable. This is a big long word. It just means it can't be told apart. So that would mean if I had liquid and I had gas, and I wouldn't be able to tell what's what. Okay, they would all just kind of blend and look the same. That happens way out here at this point on the graph. So there is, this is not enjoying writing for me. Let's try that again. There is the critical point way out there. Okay, so let's try some questions together and get you a little bit used to using this graph. Okay, so if I wanted to know the boiling point of this substance at 1 atmosphere, first of all, I'm going to put my slug in again. That's always going to help me do the slug graph. Now I'm going to use a line to kind of help me find some of the important parts that I need. It says that I really care about 1 atmosphere. So on this graph, atmosphere is a pressure, and so that happens right about there. Okay. Now, if I want boiling, boiling, remember, means that we're going from a liquid into a gas. So that happens along this line. So I want to see where those two things come together. Here's my 1 atmosphere, and here's where boiling happens. So if I try to figure out, well, okay, where do they come together? Maybe I want another vertical line like this. I want to see where all of those things come together. Okay, maybe move it over a little bit. So where all those things come together is maybe right in between 300 and 400. So I could say that the boiling point is probably about 350 degrees Celsius. I would have to heat it up that much, then it could cross from the liquid to the gas. Okay. Now, if I wanted to think about it a different way, if I wanted to think about the freezing point, then freezing means that you're going from a liquid to a solid. So I'm still going to keep my line at the 1 atmosphere, right? That's where I care about it. But now if I want freezing, I need to look between the liquid and the solid line. So that happens here, okay? Again, I have to figure out, well, where do those things actually touch and go together? So if I wanted to see where everything intersects, that's around 100 degrees Celsius, okay? Now if we actually start doing some changes, we've got a lot of numbers and things going on. So it's one of the things you might want to do is highlight and figure out, okay, where's all the numbers? What do I actually need in here? Okay, get your slug on your graph if you don't have that yet. So this tells me that I'm starting at 1.25 atmospheres. So that's like there. Okay, and the temperature that I have is 300 Celsius. What that means is I'm starting up here in the liquid section. So the phase that I'm starting with is a liquid, okay? But then it says that the pressure gets lowered to 0.25. So then I move down here to this section. That is the gas section. So we're thinking about our phase changes. We went from liquid to gas. The name of that phase change is vaporization. Okay, let's try another one like that. Sometimes I like to highlight. So let's find all the numbers that we care about for this one. Then we can find them in the question much easier. Okay, so here we're starting at 1.75 atmospheres. So that is way, way up here. And it tells me the temperature we have is minus 200, real cold here. That tells me that the phase of matter that I'm starting with is a solid. But then it says we have a temperature change where we go up to 400. So then I'm going to switch this up here to 400. Now I've moved to the liquid section. So when you have a solid that becomes a liquid, that's a phase change. And the name of that phase change is melting. So next we're looking for the temperature where the gas and liquid phases become indistinguishable. So that is the definition of the critical point. Okay, so if I look on this graph, remember critical point is way, way out here. And I'm looking for the temperature of that critical point. Okay, it could have asked me for pressure, but it just wants temperature. So I'm going to read that maybe way out at the end of the line is just around 800 or so. So the temperature that I would be concerned with is 800 degrees Celsius. And my explanation is because we were just looking at the critical point. That was the part that we needed. Now it tells us that we have a temperature of 300. Okay, that's an important number that we need. And we're going to think about condensation. Okay, so let's set our line up at 300. Oops. And I'm going to put my slug in to help myself. So condensation, just in case you forgot, means you're going to start as a gas and you're going to turn it into a liquid. Okay. Oops, I forgot to write liquid. So if I'm here, then what we want to do is put another line in. Let's kind of think about the pressure that we have. Okay, try to get my line straight. So if I go up here and I would start in the liquid, then I need to start in the gas and I need to get to the liquid, right? So I'm still in the gas, still in the gas, still in the gas. But if I get to about there, then I'm touching that condensation line that happens between gas and liquid. Okay, so that's happening at about 0.90 atm. See how it's just a little bit below 1 atmosphere? That's what's going to get me to cross that line so my gas can turn into a liquid, which is condensation. Okay, another similar one. Let's find the important things in the question. I see this 1 atmosphere and the question's asking me about melting. Okay, so let's slug this graph. So I know I have 1.50 atmospheres. That's a pressure number. And that happens way up there. Okay, and I'm looking for a temperature with melting. So melting, remember, means, whoops, that's not what I wanted. Melting, remember, means that we have a solid turning into a liquid. So I'm going to look somewhere along this line. And I need to figure out the temperature that will help me. So if I start over here in solid, I have these low temperatures, so I'm just going to keep moving this over until I touch that line and everything intersects. So that puts me right about there, so maybe between 100 and 200, then I'll be at that condensation line. So maybe 115, maybe 150. It's okay to estimate a little bit on that graph. Okay. So the next question is asking me at what temperature and pressure do all 3 phases of matter coexist? This is the definition of triple point. Okay, so we need to find the triple point on this graph. Remember, triple point is right in the middle where they all come together. So I need to figure out what are the number values for temperature and pressure there. So if I kind of check over, that maybe lines up like that. That lines up about there. And so it's okay to do some estimation on this graph. So maybe the temperature is kind of around 100. And then the pressure is a little bit below 0.75 atmospheres, maybe 0.06 or 0.65, maybe 0.70, just a little bit below that line. All right, let's try a couple more. So this one tells me we've got lots of numbers between 0.65 and 1.0. So let's find that location on the graph. So 0.65 will be kind of in here, and 1.50 is way up here. And I'm going to slug my graph so I know what I'm looking at. So I want to know temperatures where all 3 phases of matter could exist. What that means is I'm looking for spots where I'll be touching solid and liquid and gas all at the same time. So if I start with a temperature like way over here, I only have solid and gas. I don't have any liquid yet. Okay, so I want to keep moving over. I still have just solid and gas. I still haven't hit liquid. But if I move over here, that's the beginning of the triple point. So I could probably start at about 100 degrees. I would still have all 3 phases of matter. And I can keep going. I still have all 3, but then I hit the end of the solid section. If I go way over here, I only have liquid and gas. So I can only go up a little bit, maybe to about 150 degrees. That would let me have all 3 phases of matter together. All right, let's do one more kind of similar. Here are some numbers that I care about. So I'm looking between 100 and 800 degrees Celsius. So let's get all these lines off. put some new ones in so we can see what we're doing. So I'm looking about 100 and about 800. Let's line that up a little bit better. Then I'm going to put my slug in. And so again, I want to be able to find all three states of matter at the same time. So if I start way down here, I've got solid and gas, but not liquid. So I got to keep looking, keep looking. Okay, if I hit here, the triple point, then I have all three states of matter. So the lowest pressure that could happen is around 0.65. Now, if I keep going up, keep going up, keep going up, I still have all three states of matter, right? If I go higher than that, I've lost the gas phase. So the highest that I can go up is about to the end of this line right here, which is right about 1.50 atmospheres, okay? So your job right now is to first ask me any questions if you need help, and then you've got some practice online to work on this diagram. Good luck.